Hello everyone, today is April 14th, that's Tuesday, and today's lesson is on 9.2. We're going over adding and subtracting polynomials, and hopefully I will not fall down because once again I'm going to try to teach this standing up. We just don't have a good place where I can really do it sitting down, unfortunately for me. So before we get started, let's take a quick word of prayer to the Lord. And Heavenly Father, we just want to praise you and thank you for giving us this day. Each day that you give us is just a blessing, and it gives us an opportunity to learn something. And Father, help us not to worry about tomorrow. Help us not to worry about yesterday, but help us just to take your blessings and take your learning and take what you give us through the day and to trust you that what you're giving us is enough for us to get through. We love you. In Jesus' name, amen. All right, guys, so we're starting adding and subtracting polynomials. And I have a lesson opener here, which is just going to be adding and subtracting integers, which seems to be, for some of you, your downfall. You forget how to add positive and negative numbers. Or worse, probably the worst thing that you have trouble with is subtracting positive and negative numbers. So let's just do a reminder of how we do things. So I've got a lesson opener right behind me. Gonna scoot you up a little bit. So let's just look at what we remember from doing integers. If I've got 9 plus a negative 9, my rule is if my signs are not the same, I subtract and then I take the sign of the larger number. Well, 9 and then I'm adding a negative 9 means I'm going to have a 0, right? A 0. Now let's look at this next one. And we can just do it, using PEMDAS, whatever comes first, left to right. Do that type thing. So we could look at this, and I have 8 plus a negative 5. Signs aren't the same. So that means I'm going to subtract them and keep the sign of the larger larger absolute value part of that number. So 8 minus 5 would be 3. It would remain positive because 8's bigger. Then I have 3 plus 7, and that's going to become 10, right? 10. Now let's look at our next one. So I have a negative 14, adding a negative 2, and adding a negative 18. My signs are the same. So my rule for integers, if my signs are the same, are to simply add and then keep the sign. So it's going to stay negative, right? So a 14 to a 2 is going to be a 16. Then 16 to 18 is going to add up to be a 34. So that would be a negative 34. And, of course, if you're adding using commutative property, or associative property. If it was easier, if you wanted to go this way, that was perfectly fine too. Because some of you could probably say, okay, that's 20, going to add 14, that's a 34. That's perfectly fine. Now, let's go to the booger of the integer world, which is subtracting. And not only subtracting, it's when I've got negative numbers and I'm subtracting. But your rule is, if I'm subtracting, what am I supposed to do? I'm going to add the opposite. So I'm not going to subtract. I'm going to take every single subtraction problem I've got and I'm going to make it into an addition problem. And what I'm going to say is I'm adding the opposite. So I have a negative 5 and I'm subtracting a 17. That's not what I'm going to do. I'm going to have a negative 5 and I'm going to subtract. I'm going to have a negative 5 and I'm going to add what? Add a negative 17. So I'm going to say not subtraction, but add the opposite. Add a negative 17. And if I put those two together, if I've got negative 5 plus a negative 17, that is a negative 22. So that's just a quick, my eraser's way over there. That's just a quick review of adding your integers. I'm going to erase this because I'm going to have to come back over here and use this space for something else. So not so you can get a little bit Let's start over here. We're not going to really go through examples. We'll start with your homework today because you have actually done this in the past. You've probably done it in the 7th grade. You probably did it in the 8th grade. And we did a little bit at the beginning of this year. Nah. All right, so let's start to look at what we do when we're adding and subtracting polynomials. There's a real big thing you have to keep in your mind when you're adding and subtracting polynomials, and it's like terms. Like terms, which means the letter or your variable has to be the same. But not just that, the exponent that goes with that variable also has to be the same in order for me to add it or to subtract it. The first method we're doing is almost becoming more simplified than what you've done. You all have already probably been doing horizontal adding and subtracting, but just in case this totally confabulates you, they do some vertical adding and subtracting with you as well. So let's look at some of your homework and let's try that. Then we'll do some horizontal. And then I'm going to give you some words of advice for test and quiz that's coming up too. All right, so going to one of your very first homework problem, they have written this out for you in your homework. And once again, your homework is supposed to be like 1 through 41 odd. And of course, I'm swapping to odd so you can check yourself. I'm not checking your homework. Make sure you're doing enough homework to be sure that you understand what you're going to do on the quiz. Don't wait until you're taking the quiz and try to learn it. It's just life gets it in your brain if you at least practice it a little bit. Some of you have to do that. Some of you think you know more than you do. But, practice never hurts. So, as you notice, what I have here is I have coefficients with, and my variables m. They've already lined it up, so I have these are the same, or this is like terms with m, and then I have different coefficients. These are like terms, those are constants. Now I'm just going to simply add them together. So 3 plus 7 is 10, plus the 9 makes that a 19m. Now let's go through here. 4 plus 2, that's going to be 6. Then I'm adding a negative 12. So my signs aren't the same. I have a 6 and a negative 12. Signs aren't the same. I'm going to subtract, keep the sign of the larger absolute value number, which would be 12, and that would be a negative 6. I'm going to check myself because sometimes, I can get confused as I go through this. So that is adding. That's not a big deal, right? Adding, and it was so convenient that they did this for you, right? Let's move over to this one, because this is where the majority of you start to bog down or you forget what you're doing. They have set this up for you as a subtraction problem. They put it in parentheses because they want you to do something. They want you to go ahead and change this subtraction problem into what? If it's subtraction, I'm supposed to add the opposite. And that's exactly what we're going to do. I am not going to subtract this. You can mark this out if you want to on your homework or on your paper. But I'm going to change this to add. But I'm going to add not a positive 2/8, but a negative 2/8, right? I'm going to add not a negative 5, but now it becomes a positive 5. So let me tell you kind of what's happening when you're doing that. You remember this is what it looked like. 2a minus 5. Because you're going to do this, especially when you do horizontal adding and subtracting. That is almost telling you, hey, there is a little negative 1 right there that wants to be distributed prior to you adding or subtracting it. So when I multiply that negative 1 to the 2a, it becomes a negative 2a. When I multiply that negative 1 to the negative 5, it becomes a positive 5. And that's why adding the opposite really, really works in algebra when we're trying to add and subtract polynomials. So now I go back to my addition rules. So I have 5a plus a negative 2a. What's my rules? If my signs aren't the same, I subtract, and then I take the sign of the larger absolute value number, which would be 5. So that's going to become a positive 3a. Then my 3 and my 5, easy. Easy addition today. Yay, right? We're going to do about 3 more problems, but I want to make sure I don't forget something. So flip back over to a table they give you. That's on page 375. So on page 375, I'm going to pick this up and show you. It's this table right here that looks like that. They ask you some word questions and have, especially in your test, they ask some multiple choice questions about adding and subtracting like terms. And they are super, super, super tricky. So I want you to write this down because I've never seen, well, no, they've done it in the past. They really want to see how much you're focusing on like terms. And what they do on your test and maybe on your quiz, I can't remember. They give you something like, find the like term that looks like that, and you're supposed to find it in multiple choice. And then one of the like terms they give you looks like this. And you're going to look at it and thought, oh, I don't have any yx squares, when in reality, that's the same thing. So that's just a note for you to put down. I really need to know how I add and subtract like terms in my brain so I can be able to answer some multiple choice questions. That's called a cognitive reasoning or a cognitive thinking question. Not only that you know how you can do it, but you can also think through it. And then this is just a tricky. This to me is just plain old tricky. That's not standard form. That's not how you would write it. But I guess they're just wanting to see how much you're focusing on that. So we have 2 more questions in your homework that I'd like to do. So if you're doing homework, at least do the homework I'm doing with you. Okay, I'm getting caught on a cord here. So I hope you're not getting car sick from watching me move back and forth, because I'm almost getting car sick watching myself go back and forth. So you have a vertical problem that's on your test, on your quiz rather. On your test and your quiz, especially your test, you don't have vertical problems. That's almost, to me, baby-fied adding and subtracting polynomial. It's a way for you to understand it. It might be a way, if you're just totally lost, take your horizontal one and set it up like that, and you could do it. But they really want you to understand how to do this horizontally. So I'm going to do number 11 on page 377. It's rather long. I should have written it down, but I ran out of board room. So let me go through here. That's one parentheses. And then we are going to add the next one, which is 9x squared. I tried to choose a long one. 9x squared minus 5x plus 7. And then we have another one. I'm just going to erase a little bit of this and move this down a little bit so we can get the other section of the problem. So we're going to add 2x cubed and plus 3x and then plus 5. Now we have parentheses through here. And they really want you, whoa, I'm going to move this back a little so you can see it all. There we go. So you have parentheses through here. They really want you to understand that you don't have to worry about the parentheses. If you really want to know what's happening here, right off the bat, I could go ahead and just take away the parentheses. And before you say, wait, she's taking away the parentheses, what I'm actually doing is I'm distributing the little one that's right in front of those. And I'm just taking it out of the parentheses. So, and that's just so you can start thinking about it, especially when we get to the next subtraction problem. I thought, we'll go ahead and just do that. So what is Ms. Lamb doing? She is distributing the little one in front of each parentheses to bring these constants and coefficients out of the parentheses. Now, this is what I would do if I was doing it horizontally. I'm going to look through And I'm going to start with my variable that has the highest power because that's how I write it in standard form. That's what we talked about yesterday, is when I write a polynomial in standard form, I use my variables and I go down by the degree of those, or the exponent with those variables. So my highest, of course my variables through here, I have x's and I have y's. X alphabetically comes first, so we are going to do the x's first. So, and my highest power of x is cubed. So I'm going to add this 3x cubed to another x cubed. So I just go through here. There's my other x cubed. I'm going to add the 3x cubed to the 2x cubed. 3 plus 2 is going to be 5. Nothing happens to the exponent here because only time something happens to that exponent is if we're multiplying or dividing, and we don't do that until tomorrow. So we're done with x cubed. And you might just want to go back and say, so you can really focus on what's left, get rid of what you put together. So my next one I'm going to deal with is going to be an x, and I look through here and try to find what's my next power of x. It would be 9x squared. Do I have any other 9x squared? Any? Hello? No. That's all. So, and I can't add it to anything. Don't try to add it to any of these things because it doesn't have a like term. You're just going to bring it down. I'm just going to bring it down here. 9x squared. Because I can't do anything to it. The next thing, I still have x's left. It's x's to the power of 1. So I'm going to look. I have a 4x, a negative 5x, and I have a 3x. And here's how you might want to do that if you want to think it through. You might want to say, all right, I think what I'll do is I'll put my positive x's together because that's pretty easy. I just add them together. So if I have a positive, or you could go, but put my positive ones together, I have a 7x. Then I add the negative 5x. If signs aren't the same, I subtract, take the sign of the larger absolute value number. So that's going to end up being a positive 2x. The other way you could have done that is 4 plus negative 5. So I'm going to go ahead and take the subtract, take the sign of the larger number, which would end up with a negative x. Then I'd add the negative x to the positive 3x, which subtract, take the sign of the larger number, it would still be 2x. You do it however it's easiest in your brain. But we are now finished with all the x's. All right, the next thing I need to write down before I get into a constant is I need to write down variables. We're done with x. Do I have another variable that I need to write down? And you do. You have a negative y. Is there any other variable? No. I can't add it to the x. I can't add it to a constant. I'm just going to have to bring it down. Do I have anything else left? Yes, you have a constant left. There's not another thing I can add it to, but all I have to do is I'm going to bring down that constant, which is the number 5. This is as far as you can simplify this polynomial. You can't add those together. You can't add this to this because they're different powers. These are not like terms. So what you did is you added your like terms together, and what wasn't like, I just brought down and put it in standard form. So we've done an addition problem. Now what do you think we're going to do since this thing is, this chapter is over adding and subtracting? We're going to go down to a subtracting problem. Now on your test and on your quiz, this is how your adding problems are going to look. They're going to be horizontal, the majority of them. Maybe on your quiz you have a vertical one. I can't remember. But vertical ones they normally give you just to make it easy for you. But for your quiz and your test, it's going to look like what we just did, or we're going to look at 15. So 15, let me make sure I'm still on camera. Or that the board is. I really don't care if I'm on there or not. So I have a cubed plus 4b squared. And I'm subtracting 3c, or I have a negative 3c. And then I am going to subtract 2a cubed. And then I'm going to also, in there is a negative 12c. So let me take a look at this and make sure I have written everything down. And you can take a second and make sure I've written down everything that is correct in your book. To me, it looks correct. Normally, I have you guys to tell me, hey, that's wrong. And I don't have you now, and I miss you. So let's see if we can get through this. Once again, probably the first step to do is just go ahead and remove your parentheses. And removing the parentheses is not me being a jerk. It's just me distributing the 1 that's in front of the parentheses. So I have a little 1 and I'm multiplying it to all of those. So those are just popping out. Oop. 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 Now think about this 2 ways. The one way that I could think about it is I want to not subtract, but add the opposite, right? Don't subtract, but add the opposite. The other way, which might be the easier way to think about it, is there's a little negative 1. He's so negative. He's a little negative 1 right here. And just like most negativity, misery loves company, where he wants to spread his negativity or distribute his negativity throughout these parentheses. So that negative 1 is going to make the 2a cubed negative. So you have a negative 2a cubed coming out. What does the negative 1 do to the negative 12c? It makes it positive. So now we've removed all the parentheses using technically distributive property. So now I'm going to go back and forth and I am going to put together my like terms. And let's just take a minute before we do anything to them and look at what our like terms are. So I have a cubed and then I have a negative 2a cubed. I don't have another b squared in here, but I do have a c. I have 2 c's. To write that in standard form, we're going to write our variables by alphabetically, and then we're also going to write our variables in what's our highest power. Alphabetically, what your highest power is going to be a cubed. So I have a positive a cubed, and then I'm going to add a negative 2a cubed. So when I add that little 1 that's right in front of here, it's basically me having a 1 and then adding a negative 2. So I subtract and then take the sign of my larger absolute value number, which would be the 2, and that's going to make that become a negative a3. Because if I've got, that's what this looked like. It looked like 1 plus a negative 2. I'd subtract and end up with a negative 1. Well, we don't write that down because we have gotten a little bit savvier about that, and we're going to just write down a negative a cubed. Don't worry about me being in the screen because it's more important you see, well, I can bring it over there. Now, we got rid of the cubed ones, the a cubed. My next one alphabetically is going to be b squared. And we already talked about how the 4b squared does not have a like term. He's all lonely, right? So he does not have a like term to be combined with. Do not try to combine this with a. Don't try to combine it with c. You can't. It's like terms. So he's gone. What we have left are the c's. So technically I have a negative 3 that I'm adding a 12 to. That's technically what's happening here. C is going to stay the same, right? So I have a negative 3 plus a 12. If my signs aren't the same, then I'm going to subtract, take the sign of the larger absolute value number, which is 12. So that's me subtracting 3 from 12, which is going to end up becoming a positive 9c. Yeah, that looks really distorted there. So it's a 9c. We have one more problem that I want to do for you. You have a problem that looks like this on your test as well as your quiz. And it's normally those that on that's on your test and your quiz. We try to do it in your homework so you make sure you can know how to do it on your test and quiz. So if you're noting these, note down, hey, this is on my test and quiz, so if I'm having to do my test and it's still open book, then you can go back to it. If it's not open book, let's say we get back into school, I'm not sure what's happening. None of us do. Before you ask, who knows? No one does. God does, but no one else. But you can go back to it and you can study it, or you can refer to it when you're working on your test or quiz. So 31 is where you think, I'm right in the middle of algebra, and suddenly they're giving me all these geometric shapes. And it's like, what's up with these geometric shapes? And do not make fun of my writing or my drawing, because you guys know that artistry is not one of my talents here. Then your book has written it out like this. And once again, they are assuming that you know the definition of this word and that you know the formula or how to figure out this. Because your instructions for this says write a polynomial expression for the perimeter of each figure. So the perimeter means basically the measurement around. If I wanted to measure the perimeter of this room, I would take me a tape measure and I would measure that wall and I would measure this wall. And since it was the perimeter of a rectangle, because most rooms are rectangular, then that would be 2L plus 2W. And that's how I could figure out the perimeter of this one. Well, this is like a irregular rectangle, so all you can do is add this side to that side to that side to that side. And when we write that out, though, we have like terms that we can put together. So that's how we could do it. We could go ahead, let's just start with 2x. I'm going to start with 2x. Then I'm going to add that, which is going to be 3, and we'll put it in parentheses and then talk about it. Then I have 3x plus 1. Then I'm going to add the 4x. And then I'm going to finally add the 5x plus 2. And I have I have gone off. Let me move that part. Let me move this down. All right, so I have gone off the chart. So what we did is we took this side and we're adding it to this side, then we're adding it to this side, and then finally adding it to this side, and we wrote that out. And suddenly, that looks like what we've been doing in our homework. We've been adding polynomial expressions. So what do? I combine something like terms. I combine like terms. And going through here, my like terms are the x's and their coefficients. So I'm going to combine the 2x plus the 3x plus the 4x and plus the 5x. And then I have two constants that are left. I'm going to combine the 1 to the 2. So does everybody see what we're doing? If I wanted to, I could do like I have been doing and distribute all of these. We could distribute the parentheses out, but we'd end up with the same thing. Everything here is positive. There's really no time, there's really no need to waste time doing that. So let's just go ahead and look at it. I'm going to add 2x plus 3x plus 4x plus 5x. And you all can do that however quickly you want to do it in your brain. You all are normally much better at adding and subtracting mentally than what I am. So I have 2 plus 3 is 5. 5 plus 4 is 9. 9 plus 5 is going to be a 14x. Then I have a constant left. 2 constants are left, which is the 1 and the 2. I combine those, and that's a 3. And suddenly, that was how easy it was to write a polynomial expression for the perimeter of this figure. That's all you're doing. So guys, continue to work. If you have questions, you can text me. Your parents have my text number. You can send me a message in Facebook if you're watching it on Facebook. Hopefully I will look at those. Or you can leave a comment in my YouTube channel. I am not very good at checking the stuff on YouTube and Facebook, so it might be easier for you to text me, and I think the majority of you do have my text number. So have a good day. My screensaver is going crazy. So have a good day, and rejoice in the Lord, and stay well. See ya.